So we have a lot to cover in this video because MikroTik has finally done it. They've brought back one of the most requested features for version 7 that used to work in version 6 and people couldn't migrate to version 7 like myself because of this one crucial missing feature, and that is BFD or bidirectional forwarding detection. Now, if you don't know what that is, I'll give you a brief explanation, but I'll show you how cool this works with OSPF and BGP and why you want to actually bring that into your network. So let's get into the video. Now, I just want to say how crazy this is again that it's taken this long for BFD to come out. Now, I understand that there is some expectancies that can't really be met because obviously everybody wants BFD to work when it comes out, especially version 7, and it just didn't work. And MikroTik has given reasons for it. If you watch the MTU or the MikroTik podcast video with Kevin Myers, they do explain some of the reasoning behind it, but it's just funny to me that version 7 released back in 2021, December 06, so that's quite a while ago. And even if you look at some of the old forum posts, here's a post that's nearly a year old asking, hey, when is BFD coming out? We're still working on it or waiting for it. And you can see there's a lot of support. A lot of people want this. A lot of people need it, frankly. But the good news again is the wait is over. BFD is functional. It is operational. If we actually go to the MikroTik documentation, so help.mikrotik.com/docs, which I highly recommend you always go to if you want to figure or find something out, then we can have a look at some of the features on there. So if we look at our routing, we can find the BFD tab or option, and this will explain how BFD is set up on RouterOS currently on version 7, which features are currently not supported. So it's not totally 100% functional yet, but the base functions are there, which is great, which is the stuff that I typically use BFD for, just for some quick error detection and recovery. So this is also a great place just to show you how the configuration is actually set up, but I'll showcase a bit of this with my own lab so that you can actually see why we want or need BFD. But this is a great place to just again come and see what BFD is, and I also highly recommend looking at this routing overview or routing protocol overview from time to time, especially with every new major version release, because MikroTik tends to tell us exactly what they have changed with some of the updates, what wasn't working or what's working now. It is color coded, so if you maybe are a bit colorblind, that's unfortunate, but green is typically the stuff that's working, red is the stuff that's not working, that they're still working on, and the yellow things are obviously the stuff that they have implemented, but it's not 100% working yet. They're still working on it as well, but it is in the code. It is actually functional for us to play around with. So just something to take note of when you come and look at these protocol overviews. So actually, let's jump onto an EVNG topology that I've used to emulate a BFD network. And I'll just quickly explain what this network is doing. It is a bit of a base ISP network. I tend to set up a topology like this with 3 core or provider routers in the middle, some provider edge routers, and then obviously your customer edges that we just want to provide services and stuff to. Now in this topology, we do have an OSPF area, namely just the backbone. I haven't added any additional areas, but in essence what we want is we can see, if we look at the topology, that the 3 provider routers have multiple links between each other. And we do have OSPF set up, but it does mean if OSPF or a link fails or something happens and one of the links just can't transmit packets or data anymore, that a new path needs to be chosen. But just because of how OSPF works by nature with its hello and dead intervals and stuff like that, it takes a little bit of time for the failover to occur. And for some organizations, especially ISPs that deliver services to customers that require that 99 to 100% uptime, you want to make sure that failover happens as quickly and as seamlessly as possible. Now, this is where BFD comes into play, because BFD is a protocol that works with your forwarding engine. It works with your other routing protocols. So you can implement it with OSPF and you can implement it with BGP. And basically what BFD's job is to find out if there's an issue on a link on the interface that it's configured on. And if it sees there is some type of problem, because it sends, you can think of it, it's also hello packets between the two interfaces, between the two sites, so to say. And then if it picks up that there is an error within a certain interval, it will mark that connection as unreliable, and then it will tell the forwarding engine, hey, this link that you're always using to forward the packets, don't use it. It looks pretty bad at the moment. Use another path, and then it will immediately tell the routing protocol like OSPF, hey, stop using it. And then OSPF will just mark that link as down, and then it will start like transmitting packets over the alternate path, which is great. And it's the same concept for BGP. It does the same thing with BGP. It will tell the BGP peer, hey, this peer is unreliable, probably don't use it for now, switch to the other path, and then it does. And then when the initial path becomes available and ready and steady again, then it can also just bring that back up, and it will just look like 1 or 2 packets or something drops, which is really so cool, because that is almost like how quick VRRP works. It works in milliseconds, although you can tweak the timers to whatever your requirements are, because obviously not all links are like super close to each other. Maybe you do have some wireless links or something else where you need to take some type of latency or maybe even packet loss and stuff like that into consideration, so that you can tweak those values a little bit. But for the most part, this is pretty solid, and it works great in the data center. So a lot of people tend to use it there. I have a couple of BGP peers in my own production network that uses BFD for this reason, so that we can quickly and seamlessly fail over if something occurs. All right, so enough of the explanation. Let's actually do the BFD lab. All right, so let's configure BFD on this network, and we will start off on the ISP network, or the provider routers, because if we look at the topology, we already have multiple paths inside this network to get to whatever resources we need. Maybe it's the internet, maybe it's other sites, but we know there's already redundancy baked in. Now, it already works with OSPF. If one of these links go down, then an alternate path will be selected, but there is a problem in the fact that I'm using the base default configuration. Our hello timers are set to every 10 seconds, and then our dead interval is actually set to 40 seconds, which is the default. Now, this means that only after 40 seconds will OSPF actually realize that its peer is down, that the neighbor's down, and then it will choose a different path. Now, let me show you this in real time. It's actually really fun and interesting to see. So if I log on to the provider 2 router, I actually think I already have a terminal session open. If we look at the routing table, we can see that the default route it obtains is from 10.0.0.1, which is the provider 1 router. And if I do a trace route or tool trace route to 8888, we can see what path we're taking. So we're just hopping directly to the provider 1 router, then we get out to the internet, because this is my NAT network and we're not going to see anything else. So if I do a ping, we can see the ping is working, so everything looks good. So let's actually create a failure. Now, to do this with Eve, it's pretty straightforward. With the Pro Edition, if you are using Community, unfortunately you can't do this, but I'm just going to edit the link quality, and I'm going to make sure that we have packet loss running on the link. So I'm going to make sure I set packet loss. I'm going to apply and save that. And then once that's been done, if I go back to the provider router and I look at my routing table, we see we are still routing via the provider router, provider 1. If I do a ping, the ping is failing. And if I do a routing OSPF neighbor print, neighbor print, we can see that for 8 more seconds, our neighbor to 10.0.0.1 is still valid. So it's still going to use those routes that it had already in the routing table in the LSDB from its peers and such, or its neighbors. So if I now look at the routing table, because it should have updated, if I look at the neighbors again, we see we only have 2 neighbors now. If we look at our routing table, now our default route is going out via Ether2, which is 10.0.0.2, and it is actually hopping towards provider 3 now. And if we do a trace route, we can see it is now following a completely different path in order to get to the same destination. But it is working, we do have access, but it just takes pretty long, you know. So why is this an issue? Well, if you are using some business critical applications, or you are serving specific customers, or you are an ISP even, you want to keep downtime as low as possible. So we don't want to sit and wait around. We don't want to wait 40 seconds to fail over. We want this service now. And BFD allows us to do that because it is a supplementary protocol. It works with our forwarding protocols like BGP and OSPF to just let it know, hey, what's going on and what we're not going to do. So let's actually configure this by going on to provider 1 router. Oh, and let me just make sure that I remove that config again, because it has bitten me before where I forget this on. So apply, save, close, and let's just verify that we do fail back. So if I do an IP route print, we should see that the OSPF neighbor comes back up any second. Our neighbor is back up to full, and if I look at my routing table, there we go. We are back via our normal path. So I'm happy with that. So how do we implement BFD? Well, there's two things you need to do. Firstly, you need to actually add BFD to your router, and to do this you can go to the routing tab, you can go to BFD, and then from the configuration tab, this is where you actually set BFD up. So this is where you can specify which interfaces will be participating in BFD. You can specify stuff like address lists, which VRFs are supposed to be used, and also the time or the timer that BFD needs to use and the interval that is actually going to be testing at, which is really cool. And then the session tab, just to let you know if BFD is actually working or not working, or if there's errors. We'll actually see what the session table looks like once we've configured BFD. So let's go back to configuration, click on the plus. Now VRF, here you can select a VRF. What I do find is that this doesn't seem to be working 100% yet. You'll see what happens when we configure this with BGP. But I'm just going to leave this as blank. We're using the main routing table in this instance anyways. Interfaces, here you can specify individual interfaces, you can have multiple interfaces, or you can even specify interface lists. So you can create your own interface list and add interfaces to that list and then use that list. But for this demonstration, I'm just going to use all, and that will mean any interface can participate in BFD now. Address list, I'm not going to specify here. This is also more or less if you use multi-hop to connect, or you're expecting a session from a neighbor that's not directly connected to you. Maybe it's a few hops further along the way. Like with BGP, you might have multi-hop enabled, and that is where you're typically going to start using address lists to allow traffic from specific hops, but don't worry too much about just basic setup. Then we have our min, TX, and RX. Now this is, you can think of this as the hello timer. This is at what interval is BFD going to be working at. Now this is very important because just like OSPF, you want these values to match on either end, on both sides that you're configuring BFD on. Now by default, it is set to 200 milliseconds, which is quite a long time, but it's also not that long, because if we click on the multiplier, you see there's a 5. And what this means in essence is if 5 hello packets from BFD does not reach its destination or times out or whatever, or it's longer than 200 milliseconds, then it's going to consider that as down. And if it sees it happens 5 times, then BFD will tell the forwarding protocol it's not working or something's wrong. I'm going to discard this interface for any routing updates or anything. Use your alternate path. That is what BFD is going to be doing. Another nice thing is this forbid BFD, because maybe there are interfaces that you do not want to participate with BFD, especially if you use stuff like this all interface that I just did, but you want certain interfaces not for BFD, you can enable that, and then whatever interfaces you set here will not be used for BFD. But let's just disable that, and I'll just take back all of these timers. Although there is one thing again I want to stress. With these timers, maybe you are using some type of wireless systems and you want to also use BFD in that case, then maybe 200 milliseconds might be too fast or too slow for you or something. So you can obviously tweak this. So let's say you maybe want this to take a little bit longer, and you could tweak this to maybe something like 1 second. And all that means is it will take 5 seconds for BFD to pick up that there is an error, and then it will start considering a neighbor or peer or whatever being unreliable. But let's leave it at the default of 200 milliseconds. So I'll just hit OK, and there we go. So all interfaces in this instance can now use BFD. But is it actually running? No. If I go to my routing, I actually still need to apply this on either BGP or OSPF. So if I go to OSPF, where can I apply BFD? Well, you do that in the interface template. So if you click on interface templates, you find your interface template you want to run BFD with. You can go into it, and then it's as easy as just clicking and ticking use BFD, and off you go. Now I do recommend first making sure that both routers on either end is running BFD, because you can potentially cause drops in the network if you just use BFD on one side but BFD isn't configured on the other end yet, because BFD is obviously going to pick up that the interface is down that you're connecting to. So let's set this up on the other router as well. So I'm going to log on to the provider 2 router, also via Winbox. So we can just connect onto Ramon, get onto provider 2, and then on provider 2, it's going to be the same process really. So I can close that, routing, BFD, straightforward. I'm gonna hit all interfaces, click apply. But in provider 2's instance, I do not want Ether 3 to participate in BFD. So how do I change that? With the forbid BFD function. So I can click on the plus, select forbid BFD, click yes, select Ether 3 as the interface, hit apply. But you need to note as well that this is kind of like a sequential list as well. So you can just drag and drop this above the all interface list. And now Ether 3 will not participate in BFD. If we look at the sessions, we don't see anything yet because the routing protocol isn't using it yet. So let's go routing, let's go OSPF, and then in the interface template, I'm going to select use BFD, tick on yes, click apply, click OK, and let's also just apply it on the provider 1 router. And there we go. So if I go to these sessions now, we should actually start seeing sessions coming up. And then we see the Ether 2 BFD is up, but Ether 3 is currently down. Why is it down? If I go to the topology, the 3 to provider 3 I haven't configured yet, so obviously it's going to be down. So let's just quickly log on to provider 3 as well and configure BFD here. So what we can do is go routing, BFD, configuration, add, and let's first just do the forbid BFD on Ether 3. Yes, on interface Ether 3. So it is this interface. So it's the same type of scenario as between provider 2 and PE1. And then we go routing, BFD, configuration, add, interface, all. Hit OK. And then I'm going to go into the routing, OSPF, interface, template, print. And this is already set to use BFD. So this is probably from earlier when I first just tested the lab. So BFD is already running now, but I would just use the routing, OSPF, interface, dash template, set use BFD to yes for line object 0. So I'm just running the command, although it's already running. But now interesting, if we go routing, BFD, session print, we can see which interfaces are up and the BFD is working with. And then we can see that we do have the BFD forbidden for interface on Ether 3, which is perfect because that's what we wanted. If I go back to provider 1, we will see that BFD is up for both of those interfaces now. We can see how many packets have been sent and received for BFD. And it is actually working now. So let's test the difference. If I go back to my provider 2 router, and we do the same type of scenario. I run a ping to 8.8.8.8. It's already running. And let's do the same thing. So I'm going to go back here. I'm going to basically destroy this link with crazy packet loss. I'm going to go back to provider 2. We have 2 timeouts. 2 very quick timeouts, and that is all that the network saw that dropped. Also, if we go to our routing OSPF neighbor print, the neighbor's already marked as down. And then we also can see that the routing table would have updated, obviously. So this is a lot quicker than before. So this just saves us so much time. When you work in the ISP space, time is money, and you don't want to have an angry customer because within that 40-second window that you had the dead interval running, there was a major break-in or an app crashed or something happened, and you don't want to get into that. So just get BFD running and have everything working, and you will be happy and the customer will be happy as well. So what happens if we just bring the link back? It will just pick up very quickly as well that the link has recovered, which is nice. So apply and save that. If I go back, I can just look at the neighbors, wait for the neighbor to come back up. We see it is back up. And there we go. So that took also just a couple of seconds, but that's more or less just because of that initial OSPF neighborship process of being formed and relationships and, exchanging LSDBs and LSAs and all that stuff. But just starting up takes a little bit longer, but it's still really, really quick as opposed to, just using the good old normal hello intervals and dead timers and stuff like that. So that is BFD on OSPF. Let's look at doing this on our BGP. So let's configure BFD for our provider edges and our customer edges using BGP. And the process is really the same. We already have BFD configured on our provider equipment. Let's configure it for the provider edge now. So what I could do is with the provider edge, let's just log in via Winbox for that. So I'll open up Winbox, I'll connect to the Roman, and I'll go into the provider edge 1. And then let's just close all these windows. And then first things first, let's start by routing BFD. Then we can add the BFD configuration. So here I can say which interfaces needs to participate. So in our cases, maybe I want to make it all again, or I could make it ether 2. And technically, MikroTik says here you can specify the VRF, and I just want to explain the solution again. I do have a different routing table called customer 1, and I am spanning routing using BGP obviously, but I am using BGP VPN as well in order to import and export route distinguishers and targets and stuff like that. So this is just a very modern way to deliver services on MPLS or a layer 3 VPN for a customer. But I do have a 169.254.50.1 address, which is actually being advertised by provider 1 as a loopback address because I want to be able to fail over via either of these links for the customer edge, because maybe one is a fiber link and the other one is a wireless backup link or something. And in the event of either of these links dying, or let's say the primary link goes down, BGP must almost instantaneously figure that out and then go over the secondary path. Now I could show you the same thing and just run a ping to that IP just to show you what happens if the link currently dies, because that is the same process. So here I'm already on the customer edge. So if I do a ping to 169.254.50.1, I get a response. But let's say on the primary link, which is the fiber now, I'm going to induce 100% packet loss, and that is going to start timing out. So it kills our connection, and this will eventually kill the BGP session as well. So if I do a routing BGP session print, we can see our session to the provider edge 1 is still established, it's still valid, and it's still going to be up for like 3 minutes. So it works just like OSPF really. It has a keep alive time of 1 minute, so every minute it's actually just going to do a keep alive, and then after 3 minutes it will then in essence time out. That's how you can think about that. But 3 minutes seems very long for me for a session to like just keep on, because that means your customer is going to be impacted for 3 minutes, and that's even worse than the 40 seconds. And again, the argument is you can change the hold timers and such to lower values, but the lower you start setting it with the forwarding engine, the more weird it starts to feel, and you'll definitely start running into other issues, especially if you make it just 1 second for the hold timer or for the keep alive time and stuff like that. You'll definitely start running into some weird issues. So this is why BFD is useful, because it kind of replaces the requirement for hold timers and keep alive timers. It's kind of fulfilling that function for us. So let's quickly just configure this stuff. Let me just get rid of this packet loss so we can fail back, and then traffic and flow again. So let's just see this traffic flow again. There we go, happy. So what I can do now is on the provider edge 1, with the BGP or BFD, configure. Oh, there I'm on provider 1. Apologies. Provider edge 1, there we go. So if I go into my routing BFD, configuration, here I can specify ether 2, or let's say all again, that's fine. I'm going to set this for the customer 1 VRF, but I'm going to show you the issue that I've kind of picked up, and I'm not sure if this is normal or not, and we'll leave all of the other values also just the standard. And session, we can see nothing's happening. Let's just enable BFD on the customer edge as well. So I'll go routing BFD configuration, add interface all, apply that, and we also just need to apply BFD to our provider edge 2. So let's connect onto provider edge 2, which is the router on the far right. And let's just cancel out of that. Routing BFD configuration. Same thing, use customer 1. Have all interfaces. Click on apply. And then if we look at our sessions, actually there are some interfaces I might not want BFD to run on, but it shouldn't be too much of an issue because I do have different connections for BGP to each peer. But if you use maybe like a single connection, there might be some issues where you want to just switch out or not run BFD on certain interfaces so that you don't have any issues, especially if you're connecting to a route reflector like I am in this topology. But since I have multiple connections, this shouldn't be an issue. So let's see this 2CE1, which is to the customer edge one. What do I want to do there? I don't know why I opened up a second browser there. There we go. So 2CE1, I know that this link I want to have BFD running on. So obviously I can just go on to that BGP peer, so connection to CE1. And if we go to the extra tab, this is where you have the use BFD option. So you can just tick this, click apply, click OK, off you go. Let's go to the PE2, and this I'll just quickly do from the terminal as well. So maybe I'll just go on to here, even though I could do it from the Winbox terminal. I just like this one a little bit more. So let's go routing, BFD, print. Okay, so we've already got BFD configured. So routing, OSPF, not OSPF, BGP, connection. Let's export this. And let's also just print it to get the line items quickly. So our 2CE1 is line item 1, and it does not use BFD at the moment. So to enable that, we can do routing, BGP connection, set, use BFD equals yes for line item 1. If I export this again or print, we can see it does now use BFD. Perfect. So if I go to my customer edge, my CE1, which I just need to find quickly, there we go. If we look at the routing BFD sessions and we print this, I don't see anything there yet. Why not? Well, I haven't enabled BFD on the customer edge yet. So let's do that. Let's go routing BGP connection, print. I do have two connections here as well, so 2PE1 and 2PE2. So all I can do here is routing BGP connection, set use BFD, yes, for line item 1 and 0. So if you print this again, we can see it is now using BFD. So now if I look at the routing BFD sessions, we should see some sessions come up here. Oh, and this is actually why it's not coming up. This is what I was mentioning earlier. So if I look at the sessions, I know that they should be sessions and they should actually be working. But if I go to the provider edge and I look at the BFD here, the session just shows down. And it shows us down, and the local address is at customer 1, and the remote address is that routing table, so ether2 at customer 1. Because I do have this configuration in a VRF. If I look, it's an IP VRF, ether2 and 3 is in customer 1. So technically ether2 and 3 should be able to participate in BFD, but it's not working. So if I go to the configuration, and I just remove this use VRF option, that's actually going to fix it. Now, I'm not sure if that is normal, intentional, in my head. Maybe you can make it work with some mangles or route lookups, route rules. But, you know, I'm not going to look a gift horse in its mouth. If it works this way, where I just leave it blank and I'm just using whatever interfaces, then so be it. If I go back to the sessions, we should actually see the sessions do come up. So there we see a session has been formed with ether2 at customer 1. Which is perfect. And the same for provider edge 2. If I look at the BFD sessions, it's up. And if we look at the client sessions, it is now up where before it was down. You can see there is a U flag now. So we know that the BFD is actually working and is doing what it's supposed to be doing. So now we can do that other cool test where we run a ping to 169.254.50.1. I'm going to keep pinging that. Oh. My BGP also just took a moment to come up. Let's just make sure both my peers actually come up. There we go. So we do have the two peers that are up and running. We are receiving a secondary route via provider edge 2, and we have a primary route out via provider edge 1. So that's perfect for us. So let's run our ping now to 169.254.50.1. So it's running, and let's induce 100% packet loss on the primary link. So on this interface, I'll just edit the quality. Let's give it 100% packet loss, apply save, go back to the window, 1 packet dropped. Single packet dropped. And all that's happened now is it's literally just failed over to the second BGP peer on this PE2, and now it's traversing this other path to get to this loopback address that I've configured on provider 1, which is awesome because this means same principle. If I do maybe a trace route to 169.254, I actually think this might not show the information. Yeah, it's just going to show us the last hop, but it's because I'm using the MPLS now. But it's going through our secondary path. So if I do a route print, we can see it is only 1 route active. And if we look at the routing BGP sessions, we've only got the 1 established session to our PE2. So I can also just fix this again by fixing the primary link, get rid of all of that packet loss quickly. And then the BGP session should just come back up. So let's just wait for the established session to provider 1. It is. We do an IP route print, and there we can see now it will go out over the normal main path again. So again, BFD, it's not a required protocol, but it's definitely something that adds a lot of improvement to the network, especially in failover scenarios. Now I'm going to end off the video here. I hope you've learned something new. There's definitely a lot more values to tweak, but I highly recommend you bring up your own lab, test it out, and look at the MikroTik documentation.